Welcome to HB Tuner's Ford Gen 2 Coyote Training Part 40. This training module, we're going to be taking a look at how we can dial in our breakpoint rescaling. So if you're going up and building a lot more airflow and you're anticipating a lot more horsepower to your engine, you're going to have to potentially do a breakpoint rescale for your load axes. If you're going to be spinning the engine to a higher engine speed, you're going to have to rescale your engine RPM breakpoints. So we're going to go and talk about how to go properly do the rescaling, and then we're going to talk about how to rescale the table values to associate themselves to the new breakpoint values you're placing into the tables. We have a lot to talk about here. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at performing a breakpoint rescale on our Ford Gen 2 Coyote applications. Our breakpoint rescaling is something that you absolutely have to do if you're going from naturally aspirated to forced induction. So if you're putting a supercharger or a turbocharger setup on your Coyote engine, you're going to have to perform a breakpoint rescale. Now we're going to take a look at a forced induction specific tutorial using our template applicator to bring in pre-configured spark timing and torque based tables that need to be rescaled. So I'm going to essentially give you a way that you can just bring those right in your calibration file and get probably 80% of the way. But I still want to show you how to perform this breakpoint rescale because it's important to know the fundamentals in case you need to modify your calibration file, and for whatever reason my template applicator file is not working. It's not able to modify and bring in that data to your calibration. So it's essentially going to explain everything we need to know in order to perform this breakpoint rescale and prep your file for forced induction. So the very first thing that we need to do is open up a calibration file so you can follow along here for this tutorial. I'm going to go up here to File, Open, and I'm going to jump right into my Mustang example file folder found in our HB Tuners Gen 2 course packet. Now we can go in here to our different options, 2015, 2016, 2017 Mustang, doesn't matter which one we're opening, any of them will work to follow along with the tutorial. So I'm going to go up here to 2017 Mustang. I'm going to grab a 2017 Mustang GT file and click open. Now in here, we're going to take a look at scaling our spark timing tables as the very first thing we look at in terms of a breakpoint rescale. Let's go in here to engine and let's take a look. So if we go here from our general tab and we work our way over here to spark, we know under advanced, we have a whole lot of tables that we can work with within the spark timing routine. Our borderline tables reference our various map points that we might be calling out in our VCT scheduling. The borderline is going to act as the floor for the spark timing, or the base, the beginning of where the spark timing comes from. The MBT, or maximum brake torque, is going to act as the ceiling, and we're able to ride anywhere between the base and the ceiling in terms of the spark time being commanded based on whatever map point is being called on the VCT scheduling. We're finding that we can vary between essentially the ceiling and floor with the spark timing being altered through the knock control. So we have an advance and retard through the knock functionality. So we know how that works. We've went through that pretty extensively up to this point in the training course. Now what we're interested in doing here is learning how we can perform the breakpoint rescale in our borderline tables as well as our maximum brake torque tables, and then potentially going in here and also editing and updating some things within our knock control, all things related back into the spark timing routine. So if we go down here under our borderline area here, let's just grab our mapped point 0 table. We're going to find in this particular table the engine load here on our left axis. This references engine load or air load. This is going to be coming from our mass airflow, speed density, and throttle body data. As it's all going through that data, it calculates that air load value, and that's what we have here in terms of our tracking. So as we have more airflow coming into the engine, the load picks up. And what we're going to find is on a naturally aspirated Coyote engine, we should be anywhere between 0.9 and about 1.0, 1.05 in terms of a registered amount of load. Now, if we go forced induction, we're going to have a lot more airflow coming into the engine. More airflow means that we have to increase our engine load scaling here in the table because we're going to be eclipsing this 1.1 load breakpoint at our last row in the table. And why this is so important is because as we're having more airflow coming into the engine, we have more cylinder pressure increasing in the engine in that forced induction application. We need to go and reduce the spark timing so we can control the knock so the engine doesn't start to knock and we have a better base value to work with. If we're going up to, let's say, 15 pounds of boost, if we're running the timing that we would reference here at 1.1 load, or roughly atmospheric or slightly over atmospheric, this is going to be too much spark advance, and it will cause us to have knock conditions. So the knock sensor is going to kick in, try to pull the timing back. We don't want to do that. We don't want to overwork the knock control, and we don't want to put the engine. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.